Hey everyone, welcome to this explainer. I am absolutely thrilled you're here today because we are looking at something that is literally changing how we interact with the physical world around us. For decades, when we thought about solar energy, we all pictured the exact same thing. Heavy, rigid rectangles bolted permanently to a rooftop, usually looking like a total eyesore from 1998. But that era, it's over. Today, we're focusing on how solar technology is breaking completely out of that traditional rigid box and evolving into truly mobile power. We're talking about taking the grid, unplugging it, putting it right in your backpack, and eventually right into the very cars we drive.
So here's a question for you right off the bat. What actually happens when solar power unplugs from the grid and goes completely mobile? Well, it completely redefines freedom. It changes how we camp, how we travel, and how we engineer the future of transportation. We are witnessing this massive physical transformation of solar technology, moving from fragile and stationary to flexible, durable, and just highly dynamic.
Okay, let's dive into this. Here is our roadmap for today. 1. Solar leaves the roof. 2. Powering the great outdoors. 3. The science of flexibility. 4. Crafting flexible solar cells. 5. Building solar electric vehicles. And finally 6. The road ahead.
Starting with Part 1, Solar Leaves the Roof, the End of Rigid Constraints.
Moving right along to Part 2, Powering the Great Outdoors, Consumer Tech in the Wild.
To really appreciate where we're going, we've got to look at where we started. Traditional solar cells were always held back by their physical form, massive, heavy, and rigid. But our modern world doesn't just sit still, right? The growing demand for lightweight, portable solutions has aggressively pushed material science forward. Just look at how portable solar is transforming off-grid camping today. You no longer need a noisy, gas-guzzling generator to keep your devices charged out in the woods. Outdoor Gear Lab put these panels through the ringer, and the results are honestly fascinating. The Renogy 200 watt, that one's the all-around champion here. It balances portability and a massive 88% efficiency beautifully. But if weight is your absolute worst enemy on the trail, the Flex Solar 100 watt is an ultralight option at just over 4 pounds. And if you're living out of a van or an RV, the Bouge RV Arch offers this incredible, lightweight, tape-mounted option that literally just forms right to the roof of your adventure vehicle.
And listen, we aren't just talking about a tiny trickle of power to keep a smartphone alive either. In standardized testing, the EcoFlow Next-Gen 220-watt portable panel generated a staggering 193 measured watts of raw continuous output over a 2-hour period. That is serious, robust energy generation happening from something you can just fold up and toss in the trunk of your car.
Which brings us to Part 3, the science of flexibility, breaking it down to the molecular level.
Now, what's really interesting about this slide is how we actually get from heavy glass to something you can fold up or bend over the curved roof of a camper. It all comes down to a stark contrast in materials. Rigid cells rely on thick, heavy silicone bases. Try bending that and it'll just physically crack. But flexible cells, they throw that old rulebook right out the window. By utilizing completely different substrates, we're talking specialized plastics, thin metals, even fabrics, they become incredibly lightweight and highly adaptable to almost any surface or environment.
A massive part of this breakthrough is thin film technology. By using materials like amorphous silicon or copper indium gallium selenide, say that 5 times fast, these solar cells can be manufactured into large continuous sheets. Not only does this make them incredibly durable, which is exactly what you need outdoors, but they also maintain really impressive efficiency even when the light is low or the sky gets cloudy.
Let's move to Part 4, Crafting Flexible Solar Cells, the Manufacturing Staircase.
So it's not like bolting together a traditional panel. Production relies on a highly precise 4-step process. First up, you prep your flexible base, usually a polymer like polyamide or PET, and you get it perfectly clean. Step 2 is film preparation, where the active solar materials are applied. This can actually be done continuously, roll to roll, or even sprayed on via advanced inkjet printing or vacuum deposition, which is just so cool. Third, they use ion implantation to create the positive and negative charge regions. That's the actual PN junction where the real magic of electricity generation happens. Finally, the whole shebang is encapsulated in tough plastics like PTFE to protect it from the elements.
Let's move to and see how this builds into Part 5, building solar electric vehicles, the ultimate mobile application.
If a flexible panel on a backpack is the starting line, solar electric vehicles, or SEVs, are the ultimate finish line for this mobile evolution. We are talking about taking this lightweight power generation and integrating it directly into our daily transportation. When engineering an SEV, literally every component must be optimized, starting with the very bones of the car. Mild steel is the foundation of choice here. Why? Because it strikes the perfect balance. It's cost-effective to manufacture, it's easy to weld, and it has high tensile strength. But most importantly, it's highly ductile, meaning it can bend and absorb impact energy in a crash, keeping the passenger safe. Plus, it's 100% recyclable, which perfectly aligns with the green ethos of the whole vehicle.
But, a great chassis needs a great heart. Enter the Permanent Magnet Synchronous Motor, or PMSM for short. When you're relying on stored solar energy to move a heavy vehicle, you literally cannot afford to waste a single watt of power. This specific motor pairs beautifully with solar electric systems because of its incredible efficiency. Let's break that engineering jargon down just a bit. Basically, a PMSM uses permanent magnets in the rotor to create a magnetic field that spins in absolute perfect synchronization with the stator. Because they are perfectly synced up, zero energy is wasted trying to catch up. In the real world, this design delivers a really high torque density, meaning fantastic acceleration and hill climbing power, all while offering a remarkably smooth and quiet ride.
Of course, you can't just plug a solar panel directly into a motor and call it a day. You need a brain to manage the whole operation, and that is the motor controller. Think of this device as the critical middleman. It precisely manages the power flow from the solar panels in the battery pack, ensuring the PMSM gets exactly the right amount of juice at the exact right moment, depending entirely on how you're driving. And this brilliantly illustrates the final puzzle piece, the battery. Lithium-ion batteries are absolutely the perfect counterpart to mobile solar. They boast incredibly high energy density, meaning they store vast amounts of power without weighing the vehicle down, which is a huge deal when you want your solar panels to actually extend your driving range. They also have a super long cycle life, they can discharge power rapidly for quick acceleration, and they charge up fast the second the sun hits those panels.
Which brings us to part 6, the road ahead. Challenges and the bright future.
While the technology definitely still faces a few hurdles, like higher manufacturing costs and some durability challenges when exposed to really harsh environments over time, the momentum is moving entirely in one direction. So the crucial point is really captured in this research quote here. Driven by the increasing demand for renewable energy and the shift to sustainable development, the global flexible solar cell market is expected to grow in the next few years. The manufacturing is going to get cheaper, the cells are going to get more efficient, and the integration into our daily lives is going to become completely seamless.
The grid just isn't a physical place you have to be tethered to anymore. It's something you can literally carry with you, whether you're climbing a mountain or driving down the highway. So I'll leave you with this to think about. As this technology becomes lighter, cheaper, and infinitely more powerful, how will you integrate unbound solar power into your own mobile life? Thank you so much for joining me for this explainer, and I will catch you in the next one.